in 3.1, we looked at having a transversal cut through two other lines. So a transversal is just a line that goes through any two other lines. If those two lines, though, are parallel, then we get some nice things coming out of that. So postulate 15 comes from that. Postulate 15 is the corresponding angles postulate. So remember that corresponding angles are angles that are in the same position of the intersection of lines. So you can see angles 2 and 6 are both in the top right of the intersections of those lines. So those are corresponding angles. And if those two lines, in this case P and Q, are parallel, then corresponding angles are congruent. So we get a lot of nice properties like this with the alternate interior angles, alternate exterior angles, and consecutive interior angles that come out of this if the transversal is cutting through parallel lines. All right, in example 1, let's identify some angles here. So it says that this angle right here is 120 degrees, and then we've got angle 2, 3, and 4 around that intersection, and then 4 others around the other intersection. Now we are also told that this line here is parallel to this line here. You can see that on the picture. May not be super easy to see on the video, but on your guided notes you should be able to see those little triangles there indicating that those two lines are parallel. So there's 3 other angles on here that are also 120 degrees. One of them is going to be angle 4 right here. And we know that this one has to be 120 because it's vertical to this 120 degree angle. So angle 4 must be 120 degrees because it's vertical to that 120 degree angle. Now if we go over to the other intersection, let's look at, say, 120 and the 120 degree angle and angle 5 right here. Well, these two angles are corresponding angles. So they're both in the top left spot of the intersection of the lines. And since these lines are parallel, that means that angle 5 must be 120 degrees as well. And it's because it's a corresponding angle to the 120 degree angle. Well, if we know that this angle is 120, then this angle, angle 8, also has to be 120 because, well, we could look at it 2 ways. It's vertical to this angle, so since these 2 angles are vertical angles, they must be congruent. Or we already found that angle 4 has to be 120 degrees, and angles 4 and 8 are corresponding angles as well, so they have to be congruent as well. Now let's look at these other 3 that we looked at in 3.1. So again, in 3.1 we were just looking generally at a transversal cutting through any 2 other lines. In this lesson we're looking at if those lines are parallel. So these are the nice things that come out of that. So alternate interior angles, those are also going to be congruent. And if you don't remember, alternate interior angles are angles that are between the 2 lines cut by the transversal. So that's what the interior part means. Interior means on the inside. And then alternate means they're on different sides of the transversal. So for angle 4 and angle 5, different sides of the transversal, and they're between the 2 lines. Any angles in those situations when the lines are parallel, those angles are going to be congruent. So we could say that angle 4 is congruent to angle 5. If you have alternate exterior angles, the same thing is going to hold true. So exterior angles are the ones outside of the 2 lines, and alternate because they're on either side of the transversal. One's on the left and one's on the right. These are also going to be congruent when the lines are parallel. And so we could say that angle 1 is congruent to angle 8. For theorem 3.3, this is about consecutive interior angles. Now this one's different. So all the other ones tell us that angles are congruent to each other. This one's a little bit different. They're not congruent, but there is a relationship between them. And that's that consecutive interior angles are supplementary. So that means they add up to 180 degrees. So we could say that angle 3 and angle 5 are supplementary. In other words, they add up to 180. And you can see on the picture that they definitely cannot be congruent to each other. If you look at angle 5, that's an obtuse angle. Angle 3 is an acute angle. Well, you could never have an obtuse angle being equal to an acute angle. That just can't happen. But the relationship that they do have is that they add up to 180 degrees. Again, only if these lines are parallel to each other. All right, let's look at example 2 on the back side. So we're told to find the value of x. All right, well, the only thing that we have it with x is this x plus 5 right here. And we know that this angle measure is 115. Well, if we could find, say, this angle measure right here, then we could say these two together, these are consecutive interior angles. And so these two angles, this one and this one, must add up to 180. Well, this angle right here is vertical to this 115 degree angle, so it's got to be 115 degrees. So we could say then that if we take the 115 degree angle and add to it this angle that's described as x plus 5, then we should get 180. So then we could say combine like terms. We've got 115 and 5, that's 120. And then subtract 120 from both sides to get that x is equal to 60. Now we could plug this back in to get the angle measures, but for this question it just said find the value of x, so we're done. Let's move on to example 3. If the measure of angle 1 is 105 degrees, so that's this angle right here, 105 degrees, find the measures of angle 4, 5, and 8. Tell which postulate or theorem you use in each case. Well, we've got a few different options here for what we can do. Let's start with angle 4. Actually, for angle 4, we don't really have options. What we can say, though, is that since these two angles are opposite each other on the intersection of lines, they're vertical angles, so they've got to be congruent as well. So angle 4 is 105 because it is vertical to angle 1. For angle 5, this is where we're going to start having options. So we could say that angle 5 has to be 105 degrees because it's corresponding to angle 1. So angle 1 and angle 5 are both in the top left spot of those intersections. So that means that if those lines are parallel, they've got to be congruent to each other. And the lines are parallel. We could also say that 4 and 5 are alternate interior angles. So 4 and 5 are between the two lines, and they're on different sides of the transversal. And so we can say that they've got to be congruent because they are alternate interior angles. Now for angle 8, we could have, we've got a lot of different options for this one now. So it's also going to be 105 degrees. We could say that it's 105 degrees because it's vertical to this angle that's 105 degrees. We could say that it's got to be 105 because it's corresponding to angle 4. So angles 4 and 8 are both in the bottom right spot of the intersection, so they are corresponding angles. Or we could say that angles 1 and 8 are alternate exterior angles, and so they've got to be congruent because of that as well. So lots of different ways that we can justify these. Example 4. So for this one, we have a polygon. In fact, we have a quadrilateral. That's a four-sided shape. And in this quadrilateral, we are told that this line, or this side, is parallel to this side. So this is actually something called a trapezoid, where you have one set of sides congruent, or it's parallel to each other. We're also told that this is a 90-degree angle right here. And then for the other angles, we have this one's called 3x, this one's 2y, and 7y. So let's see if we can find the values of x and y. Well, let's start with x. X is going to be a bit easier. So we know that these lines are parallel to each other, and that this is a right angle. Well, that's enough information for us to find x. So if this is a right angle, then this one also has to be a right angle. So if you think about a line cutting through two parallel lines, if it's perpendicular to one of the parallel lines, then it has to be perpendicular to the other parallel line, to the other line that's parallel to the original line. So that 3x has to be a 90-degree angle as well. So we could say 3x must be equal to 90. And then we can solve this by dividing both sides by 3. So then x must equal 30. To find y, it's going to be a little bit trickier. So we need to, again, pay attention to the fact that this line is parallel to this one. So let's think of these as lines extending further than the shape itself. So there's two parallel lines, and then we've got a transversal cutting through like this. And so this angle and this angle are consecutive interior angles. And so they're going to be supplementary. So we know that if we take 2y and we add to it 7y, we've got to get 180 degrees. These are supplementary angles. We've got like terms here, 2y and 7y, that's 9y, and that equals 180. And then we can solve by dividing by 9. So then y must be equal to 20.